Hey everybody, I am trying to figure out my technology. There we go. So hello, welcome to week 1 of my wrong course, semester 1, prep for pre-cal. And as you can see, I'm a little scattered because it's my first week doing this and I had to figure out technology from home and all of that stuff. So bear with me. Luckily, I think you guys all know me, so I don't have to give any pretense that I'm perfect and flawless as a teacher. You guys know better than that. So week 1, I went through chapter 1 because that's the first chapter that they cover in Pre-AP Pre-Cal. I've seen the planning calendar for this coming year, so I had some ideas and then I changed them once I saw the way they had the planning calendar scheduled for this year, so that we got the most bang for your buck as far as you using this to help you be ready. So the first thing that y'all are going to talk about in the very, literally the second or third day of pre-cal when you're ready to get going is you're going to review some formulas from geometry. One of them is the distance formula, one of them is the midpoint formula, and one of them is Pythagorean theorem. And I think that those are probably pretty easy for you guys, but just to review, I felt like we should do an example of all three. So we're going to do, we have a picture here from Delta Math that gives us 2 points, and we are going to find the distance between those 2 points using Pythagorean, you can use Pythagorean theorem actually, but we're going to use distance formula. And then we're going to use midpoint formula to find the midpoint of this segment. We're also going to use midpoint formula to show you how if you have the midpoint and one endpoint, you can find the other endpoint. And then we're going to practice some Pythagorean theorem problems, which you only use with right triangles. So let's look at this first page. We've got a bunch of pages to go through, so if I go too fast, you can always pause me to catch up. But I don't want this to be a 45-minute video, and I know you don't want that either. So if we look at this, we have the point 2, -1, and the point 9, -3. I want to encourage you guys, especially in pre-cal, because I went in and played with the online textbook, which is where a lot of the homeworks and the tests will come from. Be sure to always check the scale of your graph because they are not always going to be counting by ones. And sometimes the x-axis will be counting by different increments than the y-axis. So please always don't just assume that every grid line represents 1. It does here, but I'm telling you it's coming, where you need to be very aware of what the grid lines are counting by. So for distance formula, we're going to subtract the x's, the x coordinates, so 9 minus 2, and we're going to square that difference. We're going to subtract the y coordinates, which when we put minus -1, that really turns that to a plus. We're going to square that, and we're going to simplify. So 9 minus 2 is 7, and 7 squared is 49. -3 plus 1 is -2, and -2 squared is 4. Yeah. And we're going to get that the distance is the square root of 53. If it could be simplified, you should do that. 53 is not a simplifiable radical, so you would type this in as your answer. Now we're going to repeat using those 2 ordered pairs, but now we're doing a midpoint formula. So midpoint is the middle of these x coordinates and these y coordinates. And so you could probably do that in your head, but just to be safe, let's do it using the formula. So basically you're finding the average of 2 and 9, which would be 5.5, which you can write this way, or you could write as 11 halves. And then we're going to find the midpoint between -1 and -3, which is -2. But if we did this using the formula, it'd be -4 divided by 2, which is -2. So you could type this in this way. You also could type in this as a fraction. Okay, and then there's what if you have the midpoint and you're looking for the other side? You've got one side's endpoint, you need the other side's. Well, you could use the midpoint formula. We know that for this endpoint plus another endpoint's x-coordinate divided by 2 would get you 0. We know that the y-coordinates, if I add 3 and the other endpoint's y-coordinates and divided by 2, I would get, this is actually a -1. You also could just think about it in your head, like, okay, the midpoint is 0. One side of it is 4, which is 4 away from 0. The other side of it is for less. Oh, you get to see my bunny freak out. That's awesome. Okay, so you could do it either way. I'm going to just say that we're smart enough to know that 0 to 4 is going forwards by 4. So I'm going to go backwards from 4. The other end point would start at -4. -1 to 3 is an adding of 4. So I'm going to take away 4 from -1, and that would be -5. And that would be the midpoint. All right, so now we are ready to move on to Pythagorean theorem. And Pythagorean theorem, if you look up here at the top, is a squared plus b squared equals c squared. Please remember that a and b are both legs of the right triangle, which means they're the sides that create the right angle. And then the hypotenuse is the longest side. It is not equal to these two added or anything like that. It's longer than either of these sides, but it's shorter than the sum of these sides. So it's not going to be 6 or anything bigger than 6. It has to be less than 6. And it's probably going to be a radical. When we get into pre-AP, pre-cal, we rarely are going to find whole number hypotenuses. Or hypotenusae, maybe that's the word, I don't know. So I'm going to take this leg and this leg, square them and add them together. So 4 squared plus 2 squared, it doesn't matter which is A and which is B, equals the hypotenuse squared. So this would be 16 plus 4, which is 20. And if I take the square root of 20, that would be C, but I can simplify that because 20 has a 4 in it, and the square root of 4 is 2, and that leaves a 5 behind. So the hypotenuse length, you would type it in this way in simplified radical form. If it asked you for a decimal, then you could round, but otherwise you should leave it exact. And then let's practice a word problem. If you start driving east, so you're here and you drive east for 14 miles, turn left and drive north for 6 miles. At the end of your driving, what is the straight line distance from your starting point? See how that makes a right triangle? So we're going to use 14 and 6 as our legs. And this is giving us permission to use a decimal. So I'm going to do a squared plus b squared equals c squared. Obviously, this is the hypotenuse. 14 squared is 196, and 6 squared is 36. Oh boy, I should have done this ahead of time. So these get us 232. And now y'all are catching me with my pants down. Let's go to Delta Math. Luckily, they don't need us to simplify that radical, so I'll just type that in. And we get 15.2. I think we said the nearest tenth, right, was what they asked for. 15.2. So we'll go back. Nearest tenth of a mile, yes. So 15.2 miles. And you don't have to use units unless it tells you to. In fact, I think it'll give you an error or count it wrong if you type in miles. Okay. Another thing that y'all review at the very beginning, and y'all go through this so quickly, is just reviewing your basic equations. And that can include things with fractions, that can include things with distributive property, that can include cross multiplying, that can even include some simple quadratics. So we are going to solve for the missing variable. So I'm going to, or for the only variable, I should say. I'm going to take away 20 from both sides. I like to get rid of a fraction by multiplying by the reciprocal. So I can do that here and here, and that would give me 24 over 3, which is 8. And that fraction and that fraction cancel out, so z is 8. This is a minus, by the way. These are really faint, and I don't like that on the notes. You might want to darken the notes when you print if it's not too late. Or you might want to do it again if you look at it and think it's too dark. So if we were, and I'm going pretty fast through this, so if I make a mistake, you guys can tell me, but it'll be too late for me to do anything about it. So I'm trying to move quickly but accurately. So I end up with negative x equals 8. That means x equals negative 8. This one is a cross multiplying. Now it's not 9 times just 5x. It's 9 times this whole thing. So 9 times this and 4 times this. So if I write that out, that would be 45x plus 72 and 20x minus 4. And I'm going to move the constants to be together and the coefficients to be together. So that would give me 25x equals negative 76 divided by 25. You can write that as a fraction. That cannot be simplified. You could also write it as a decimal only if it is not a repeating decimal. It's got to be a terminating decimal that ends. Notice that on D and E, it's asking you to solve, but it's only asking for real solutions. So if at any point you have to take the square root of a negative, that is not going to be a real solution. That's imaginary, and that's not what they're asking for. Also, make sure that if you have a radical, it's fully simplified if it's real. Okay, so if you look at this, this is a quadratic. It's a pretty basic quadratic. It doesn't have a linear term. It just has a quadratic piece and a constant. So you can move the constant to the other side, and you can square root. And you get plus or minus the square root of 8, which can be simplified a little bit more. Don't forget the plus or minus sign. If you bring a square root into a problem, you have to put the plus or minus there, unless it specifically tells you that it only wants the positive solutions. Now, if we look at this one, we get to a place where we are going to need to take the square root of a negative number, and we don't do that when they're only asking us for real solutions. So you will just leave this one blank because it is no solution, and Delta Math treats an empty set like it is a no solution. All right, so let's remind us about intercepts. Now, an intercept, if it doesn't say X or Y, if it asks you for intercepts, it is asking for any and all intercepts. X-intercepts we know are on the x-axis. If we write them as an ordered pair, the y value is going to be 0. A y-intercept is found on the y-axis. It will always have an x-coordinate of 0. So any function that you are given, you should be able to easily find the y-coordinate of the y-intercept by plugging in a 0 for x. And so I will do that here, and that will give me 2 times 0 plus 3 times 5 times 0 plus 1, and that would be 2 times 3 times 1. 2 times 3 times 1, which would be 6. So if they ask you for the y-coordinate, they just want the y-coordinate. If they ask you for the y-intercept, you need to write it as an ordered pair. How many x-intercepts would this function have below? So every factor that is unique, that has an x in it, represents an x-intercept. The only exception to that is any factor that if you solved it for x, you would get an imaginary answer. This would be such one. That is not going to cross the x-axis. That is an imaginary x-intercept, so it doesn't count. So we have this one, we have this one, and we have this one. So I can have x equals 0. X minus 9 equals 0 would give me x equals 9. And x squared minus 2, if I set that equal to 0 and solve, I would get not 1, but 2 x-intercepts. So I have 2 here, that's a third, that's a fourth. So I end up with 4 x-intercepts. The only ones that I couldn't count would be this one that had an x squared plus something constant. That's always going to give me, like this up here did, an imaginary solution, which is not a visible x-intercept. Now, if you're given a problem like this, and they ask you, this is just linear, they ask for the x and the y-intercepts. This is a standard form linear. If I want to find the x-intercept, I'll plug a 0 in for y. If I want to find the y-intercept, I'll plug a 0 in for x. Super easy to come up with. So the x-intercept, if I put a 0 in for y, would just be 10. So 10 comma 0 is an x-intercept. The y-intercept, I would be plugging in a 0 for x and solving for y, and that would give me negative 7.5. And so my y-intercept, written as an ordered pair, would look like this. So I have one x-intercept, one y-intercept. Determine the x-intercepts of the following equation. Okay, again, this is a little bit faint, but this is what this looks like. This is in factored form. Every factor that has an x, just set that equal to 0, because remember, y is equal to 0 when we're looking for x-intercepts. So I am just solving for these two x's. So I'm going to get x equals 4. So 4 comma 0 is an x-intercept. I'm going to take away 1 and divide by negative 1. and I get x equals 1, which means 1 comma 0 is my other x-intercept. So this is the two places where this function would be crossing the x-axis. Okay, now we're going to use technology. And if I tell you to use technology, then I am totally okay with you using an Inspire or the Desmos calculator. If I don't tell you to use technology, then you need to do it algebraically. We're to that point where, unless you're told otherwise, you should not be using technology to answer these. And that's going to really bite you when you're taking your tests in pre-AP Precal, because they will have a lockdown browser and you will have only access if it's on the computer, which it may not even be, but if it's on the computer, you will not be able to access any site other than the textbook, and you won't be able to use Desmos or anything like that. So we are being asked to find the zeros of this function. Remember, zeros are the same thing as roots, solutions, or x-intercepts. Those are all the same. So we're looking for, where does this graph cross the x-axis? It probably crosses twice, maybe once, maybe none. So I'm going to go type this into a Desmos calculator. Where do I want to be? Okay, Desmos graphing calculator. I should already have had that up, sorry. And I'm going to go type this in. You can use y equals if you want, or you can just use, you can just start it right here. I used the wrong x plus 1. And we can notice, and it says, I think, round to the nearest hundredth. So negative 3.35 comma 0 and negative 0.15 comma 0. So those are the two x-intercepts. So that would be what I would have written right here. 3.35, negative 3.35 and negative 0.15. Those are the nearest hundredth, two decimal places. Now it asks you to do that again, find the roots, same thing as zeros, but also find the vertex. So we're going to practice finding the vertex. And remember, you have to decide if the vertex is going to be a maximum or a minimum. This is supposed to be a minus sign here. So I know this is going to be an upside down facing parabola, and I'm going to have a maximum vertex. This says round to 3 decimal places, so hopefully Desmos will help us with that. So I'm going to type in negative x squared plus 8x plus 48. And I might need to zoom out just a bit. Well, I don't have to see the vertex. So I can't see it. All right, so I have one. Okay, it says if necessary. So the roots are going to be negative 4, 0 and positive 12, 0. And if I look up here, the vertex is a perfect integer for the x and the y. And I'm just going to make sure that we notice that that was a maximum. So if you look at the paper, this is what I've got. Here are the roots, here's the vertex, and it is a maximum. All right, now we're ready to move on to our linear equations. We hardly spent any time in Algebra 2 on linear equations because basically the first half of Algebra 1 is practicing this. So we expect you to remember it because you also did some of that in 8th grade math. So the most important part of a line is the slope. You know the slope measures steepness and direction of a line. You only need 2 points for slope. Another phrase that means slope is rate of change. So this is our traditional slope formula. Sometimes it's referred to as the change in y over the change in x. All lines have a numerical slope. The only exception is a vertical line who has a word for its slope. It's called undefined because there's no change in the x coordinates and we don't have anything for that, a number to represent that. Horizontal lines have a slope of 0, and you remember that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So first, let's just practice using slope formula. I've been given 2 points, and they want to know the slope of that line. So I'm going to use the y is on top, subtracted. In the same order, the x is on bottom, subtracted. So I reduce this to 12 over 9, and that reduces even more by 3 to 4/3. And so my slope is 4/3. Simplest form, make sure you reduce a fraction. And make sure if there's a negative on top and bottom that it cancels out. Here's an example of a graph. Now the grid line's barely printed out. Of course, you're going to be doing your assignment on Delta Math, so you'll clearly be able to see the grid lines. We're just going to pretend like we can see clearly that the y-intercept is down here at -2, and it is counting by ones, and I'm going to count a slope of up 3, left 2 to get a negative sloped line. You could have also counted down 3 and right 2 and gotten a point on that same line. So I believe it only requires 2 points for you to connect those dots, and that's a picture of that linear equation. All right, more linear. There's 2 other forms of a linear equation other than slope-intercept form. We have point-slope form, which is great to use when we have been given a slope and just a single point, and standard form, which is not usually something that we ever start with, as far as we don't ever write an equation in standard form to start with, but sometimes we are given it and asked to convert into one of the other forms. So an example would be, what is the equation of a line that passes through this point? So I have a single x and a single y, and I have a slope of -1/2. So I'm going to have to put that in point slope form. So y minus the y coordinate equals the slope times x minus the x coordinate. And so I will turn this into slope-intercept form by distributing the -1/2 and then moving the y1 value over by changing the sign. So I end up with y equals -1/2 x plus 7. And now I have that in a graphable form, although it is completely graphable starting at that point and counting that slope. What if you're given a equation in standard form and they want you to put it in slope-intercept form? Well, that just means you're solving for y. So I'm going to add 3x to both sides, and I'll divide by 2. And some things will have to stay fractions, and some things will reduce not to be a fraction anymore, 18 divided by 2. Let's review the equation of vertical and horizontal lines. Horizontal lines have a slope of 0. They look like this, right? More horizontal than that, like this. Every point on that line has the same y coordinate, which is why the equation is just y equals that constant y coordinate. The best example of that is the x-axis. It is a horizontal line, and every coordinate on that line has a y value of 0. So the equation is y equals 0 for that horizontal axis. Vertical lines have an undefined slope. The equation for a vertical line is x equals all of those x coordinates that those points share. The best example of a vertical line equation would be the y-axis. It's a vertical line, and every point on that has an x coordinate of 0. So the equation of the y-axis is x equals 0. Now here they're asking me to graph a line. You have to decide what type it is. It starts with x, so of course it's vertical. And then I'm going to go to the x-axis to -5, and I'm going to draw a vertical line through it. You may have to plot 2 points and then connect it with a line, but that's easy enough. Now, if they've already given you an equation or a graph, you need to look at what type it is. This is definitely horizontal. So that means my equation is going to be y equals, and you look at where it crosses the y-axis, which is +5. And that's your equation of that horizontal equation. Done with that page. We're getting close to being done. One more thing. What if you've been given just 2 points and you have to put it in a particular form? In this case, it's point-slope form. So I need to find the slope, and then I can pick either this point or this point and put it into point-slope form. It doesn't matter which point I choose. The only exception is if it's a vertical or horizontal line, you would see either the same x-coordinate or the same y-coordinate, and you would, if it was the same x-coordinate, you'd write x equals that number. If it was the same y-coordinate, you'd write y equals that number, and that's a special case. That's one of these two. So I'm going to use slope formula, and I'm going to subtract the y's on top and the x's on bottom. That gives me -16 over -3. So +16/3 is my slope, which I don't like, but that's fine. And now I'm going to use this as my first x and my first y, and I'm going to put this in point slope form, which looks like this. And you could have done the same thing with the -8 here, but it would look like a +8, or you could put the 1 here, and that would work. Now we need to talk about parallel and perpendicular. Remember that that's a topic you discussed in geometry and in Algebra 1. So we expect you guys to remember that, but we are just going to do a quick review. Remember, lines that are parallel don't touch. It's because their slopes are exactly the same. Same number, same sign, exactly the same. Perpendicular lines, that's not the case. They do cross. They cross at a perfect 90-degree angle. The reason that happens is because those slopes of those two intersecting lines are opposite sign and reciprocal numbers. So one's positive, one's negative, or one's horizontal, one's vertical. And the numerical value of the slope is flipped. So if one of them has a slope of -2, then the other one's got to have a slope of +1/2. The way you know that two lines are perpendicular is if you know their slopes, multiply them together, they should equal -1, that product. So let's look at this. It says, which equation represents a line that is parallel to this line? Now, if you look at this, the slope is -4/5. That means the parallel line should also have a slope of -4/5. So we just need to look at these equations and pick the ones that when we move the x's to these are all in standard form. When we move the x's to the other side and then we divide by the y coefficient, we should be getting -4/5. I'm going to skip ahead and take us to this one. So I'm going to move the 4x to the other side by subtraction. And when I divide by 5, you should see, doesn't even matter what the y-intercept is, but you should see a slope of -4/5. That's the right answer. Okay, what is the slope of a line perpendicular to this one? So here's what we need to do. We need to find the slope of this line and then flip it and change the sign. That's all we want is the slope. So I'm going to move the 2x to the other side. I'm going to divide by 10. All I really care about is this right here, and that slope is -1/5. Now, perpendicular to that would be a slope of, flip it, 5, take away the negative, +5. This would be the perpendicular slope. What is the equation of a line that passes through -5, -2, and is parallel to this line? Okay, so we need a whole new equation. But first we need to find the line that we were given. We need to find its slope. Then we'll take that, use this x and this y, put it into point slope form, and get our equation. So I'm going to move the x to the other side, and all I have to do now is divide by the negative that's in front of y, which will change all of the signs, and that will give us a +1x slope minus 5. All I care about is that slope right there. Parallel means I want to use that same slope with this point in point slope form. So y minus y1. y1 was negative, so that changed this to a plus. The slope is 1, x minus the x coordinate, which is also negative, so it's going to change this to a plus. Now you could leave it in this point slope form, or you could go ahead and move it into slope intercept form, which would be x plus 5 minus 2. So that would end up being that. So either one of these, I believe it accepts either one. Those are considered equivalent lines. Okay, and then lastly, and this is something that we did at the end of Algebra 2, was the equation of a circle. It was also covered in geometry during the circle unit, but if you were in geometry 2 years ago, you wouldn't have gotten this because of COVID, unless you took it in summer school, and I'm not even sure then that they had time to cover that. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. H and k are the coordinates of the center, which should be hopefully fairly easy to find. Again, these grid lines did not print well, but I can see that this is -5, -7. And the radius is the distance from the center to the side. And I even can't tell that very clearly. I think it goes from -5 to -2, which means the radius is 3. So if you can find the coordinates of the center and the radius, you have the ability to write the equation of the circle. X minus h, if h is negative, it would become a plus here. Always a plus in between these two. Y minus the k coordinate, which was also a negative, squared, equals r squared. So 3 squared would be 9. Now let's review what if it's not in standard form. This is called general form. We had to practice in Algebra 2 this year how to complete the square. So this is a plus, this is a minus, this is a plus, this is a plus. So I'm going to rearrange so that I leave some space to complete the square. This is a minus 14x, and I have a positive y squared and a positive 8y, and I moved that 61 to the other side because I'm going to need to complete the square. So half of negative 14 squared would be 49. I'm going to add 49 on both sides. Half of 8, which is 4 squared, is 16. I'm going to add 16, and then I can complete the square. So I end up with this. You're taking whatever was half of this number. That's the number that shows up as your h and your k. And then these two added up to 65 minus 61 is 4. So I can tell that my center is 7, negative 4. And the radius is the square root of that number. Remember, the square root of 4 is the radius. All right, and then the last problem, and we are in the final problem. What if you're given the center? This is 6, 3, so there's h and k, and you're given a point on the edge of the circle that is not clearly going to give you the radius. But I can use any x, y, h, and k to get a radius. So remember, this is our formula. And we can solve for r if we have values for everything else, which we do. So the x value I was given is 9 minus the h, which was 6. The y coordinate I was given was 4 minus 3, which was the k coordinate. And we're going to solve for r squared. So this is 3 squared, that's 10. I'm sorry, that's 9 plus 4 minus 3 is 1. 1 squared is 1. I get 10. That's my r squared. And guys, they don't even want the radius. They just want the formula, the equation. All I need is r squared for that. So I'm going to use the h that they gave me, the k that they gave me. I'm sorry, that should be a minus there. And the r squared that I just found. And I'm done. And if you got through all of this, then you are good to go on the assignment. It's long, so just pace yourselves and do a little bit every day. You guys have a great week, and I'll see you next week.